So we are discussing about decision tree algorithm. Decision tree algorithm is one of the most primitive algorithms we have as a classifier. So for that we are considering this data set. In this data set we have 5 attributes. Out of these 5 attributes, this last attribute is the decision attribute that we are going to predict, which is buys computer. That means the customer is going to purchase the computer or not. Such kind of machine learning model we are going to make using decision tree algorithm. So decision tree algorithm is one of the most primitive algorithm, and it has tree like structure. So here age, as I said, less than 30 we'll consider it as youth, 30 to 40 is considered middle age, and greater than 40 is senior. Okay, so this such kind of data is there. And in income group also 2 types of income group, 3 types: high, medium, low, student or not student, credit rating, fair, excellent. So this is credit rating, okay, might be provided by some agency, who don't know. So this data set, based on that we are going to implement the decision tree. How it will happen? So decision tree looks like this, students. So it has a leaf node. Okay, we'll come to it. It has leaf node, and these are internal nodes. Okay, and this algorithm has been developed by Quinlan. Okay, Quinlan, and it is referred as ID3. Okay, decision tree is first decision tree algorithm is ID3, which is developed by Quinlan. Okay, so this algorithm works like a greedy algorithm. So greedy algorithm, you know, it's basically it finds a locally optimal solution. Greedy algorithm finds locally optimal solution. Let me write here, locally optimal solution. Okay, so locally optimal solution means it is not at all optimal. Like maybe optimal. Okay, like, you know, greedy strategy, this one knapsack problem, you might have known greedy strategy, right? Where the algorithm tries to find the whatever is available to it, he will just jump onto it. You won't think about anything future, what is going to happen. So that is called greedy method. But dynamic method is just the opposite of greedy method, where you will get always globally optimal solution. So let us say one example of greedy method is what? Let us say you are going from one place to another place, source to destination, and if there are many options are there, out of that many options, whichever options maybe immediately a very low cost option, will choose that. That is greedy method. So greedy means lalchi in Hindi, right? So that is greedy, but it doesn't mean that if you choose that that minimum path, you will be always getting the cost will be minimum while you will reach your destination. It's not like that. Maybe locally it seems like it is minimum, but when you reach the destination, you may find that you have chosen a wrong path. Okay, so that is called greedy method. So in knapsack problem, you might have got this 0-1 knapsack problem, how greedy method fails and all. Okay, so greedy method is in let's say this is, if you consider this graph, I'm just giving you very quickly, and this is, let us say 2 3, and then let's say this is 10, and this is let's say 1, and this is 2, this is 2. Okay, so what greedy fellow will do, he'll start from here, and I'm asking him from here, from source to destination. I'm asking the person to go from source to destination. What greedy method the fellow will be applying greedy method, what he will do, he will say, okay, this is 2, so I'll choose this path. But this path, actually after coming here, it is 10 and then 2. That means 10 plus 2, 12 plus 2, 14. So total 14. Cost is 14. Whereas here it looks like 3 immediately. But 3 plus 1 plus 2, which is nothing but 4, 6. So this is minimum cost. So this path actually gives minimum, but the greedy method might choose this one, because immediately it is through, it is 3. So that's why he always choose the immediate best, without thinking the global solution. So this is how greedy method works. So locally optimal solution. So tree is constructed in a top-down recursive divide and conquer manner. At start, all the training examples are at the root. Attributes are categorical. Examples are partitioned recursively based on selected attributes. Test attributes are selected on the basis of heuristic or statistical measure. Okay, and that is called information gain. So there are many things are there. We are not going into the terminology now, which is heuristic and all. We will just simply go through the algorithm and we will solve the problem. Okay, so okay. So what happens, and then condition for stopping partitioning, all samples for a given node belongs to the same class. There are no remaining attributes for further partitioning, and majority voting is employed for classifying the leaf. There are no samples left. Let us see the algorithm first. So here, to understand the decision tree algorithm, we have to understand entropy. So entropy, you might have already come across this terminology, which is entropy, which is related to the information. Okay, information theory, you might have got this terminology. What is entropy? Entropy is a measure of uncertainty associated with a random variable. Calculation for a discrete random variable y taking m distinct value y1 to ym. Entropy y h y is nothing but minus I equal to 1 to m pi log pi. So if you just open this summation, what it will become? It will become p1 log p1, and then let's say only let's say, what is I is nothing but, okay, let's say only two examples are there, y1 and y, not two example, distinct value y variable where two instances are the y1 y2. So in this case, p1 log minus p1 log p1 minus p2 log p2. Okay, such kind of scenario we have where pi equal to this. So interpretation is higher entropy, higher uncertainty, lower entropy, lower uncertainty. Okay, and then we have conditional entropy, which is h probability of h given x. This can be written like this. Okay, this is called prior conditional probability. So conditional probability means when the probability of some variable is depend upon other variable, so that is called conditional probability. Okay, if it is not depend, then it's called prior probability. Okay, so attribute selection measure and information gain. Select the attributes with the highest information gain. Now this is the second terminology you have to understand. Which attribute is having highest information gain? We have to choose that attribute. Okay, we have to choose that attribute. So entropy is the first term that we are discussing here. Entropy, first terminology you have to remember, and then after entropy, and then we have this another terminology which is information gain. Okay, so what is information gain? The highest information gain attribute has to be chosen. Okay, we will be having many attributes in the data table. Here in this case, we have age, income, student, credit rating, buy computer. So these four are the independent attribute. Which attribute has to be splitted further, and how to go? Because here you can see the diagram. Here age, we should go this way, or we should go this way, or we should go this way. So three ways we have. Out of these three ways, which ways have we chosen, so that we'll get the correct classification? Okay, so that is the intention. So that classification will be based on the information gain, who is having maximum information. That attribute will be splitted further. Okay, that attribute will be splitted further means, here if you choose this attribute, let's say for example I'm telling it has this and this. Okay, it has this and this, or let us say from here this attribute is chosen, it has these three options. So here what is the information gain? Okay, what is the information gain here at this point? So those things you have to calculate. Whichever is having the maximum information gain, it will be split further. Okay, that means you will find the way to go deeper to the tree. Okay, you will find another to deeper to the tree, that means to the leaf node. Once you reach the leaf node, then only you will get some class. Then only you will get some class. You know, this is leaf, this is leaf, this is no class, this is yes class, this is no class, this is yes class. Okay, here this is also a leaf node which is yes class. So this is the outline of the algorithm. Okay, now let Pi be the probability that an arbitrary tuple D belongs to class Ci estimated by modulus of Ci comma D divided by mod of D. Okay, expected information entropy is nothing but this formula. Just now this formula we have discussed. Entropy can be written as info D. What is D? D is nothing but attribute. Okay, info D summation 1 to m. Okay, m is number of classes, I suppose. If this is binary classification, then m will be 2. Here I think I have wrongly said you. Here it is not attribute. This is m is nothing but class. Let's say binary classification n is 2. So this is p log p1 and minus p2 log p2. Okay, so such kind of thing. So and then information needed, info A. Let's say I want information for attribute A. So attribute A is which one? This is the attribute A. Let's say this is my attribute A. Age is my attribute. So first you have to gain the information for the whole table, which is D, And then for individual attribute who is having maximum information gain, you have to choose that attribute. Okay, so that formula is nothing but this one, info AD. So info AD is this is given like this. We'll see that modulus of dj by d into info of dj. Okay, so info of dj, so this is there. Information gain by branching of attribute A is nothing but info of d, that means total information gain minus the information gain for attribute, particular attribute A. So that value will be giving you the output. That output will decide whether you should go with A or whether you should go with attribute B or whether you should go to attribute C and other attributes, whether which attribute should be splitted further. That will be depending on this gain. Okay, information gain. So which are the formula? Right now we have checked information D for the whole thing, and information for the attribute, for a particular attribute you have to find the information, and then for each attribute you have to find the gain. Okay, now you see here this is the table, remember the table. Okay, now next we have two classes here, one is yes, another one is two. So two class, the decision attribute is having two classes are two, which is yes and no. So yes is the positive class by computer yes, and no is the negative class by computer no. Okay, now first we are going to find the information D for the whole table. Okay, so information D is the whole table. What is the formula? Information D one second. Yeah, information D formula is pi log 2. This is the formula, right? Pi is the probability that an arbitrary tuple of D belongs to class Ci. Okay, so this is the formula. This is the formula for information D. So Pi is nothing but the probability that an arbitrary tuple D belongs to class Ci estimated by this. So Cid divided by D. D is the total number of tuples. So here total number of tuples are 14. Okay, it is 14. So how it calculates, you see. So for yes class, 14 is the denominator and numerator is 9. We have total 9 cases of yes, I suppose. And let me see, it is 9 or what? 1 2 3 4 5 6 7 8 9. Okay, so 9 is here, 9 by 14. This is 9 by 14. Log 2 9 by 14. Pi log pi, students. Pi log pi. So pi is nothing but this one, students. This Cid by D. This is nothing but D is total number of instances, which is 14, and this is for positive example, it is nothing but 9. Okay, so this is 19 by 14, 9 by 14, and P. So formula says that minus P1 log P1. Okay, and then minus P2 log P2, because we have two classes log P2. Okay, this is there. So here it is for negative classes. How much? Negative classes is nothing but, this is for positive class. For negative classes only 5 instances are there. You see, 5 instances. So 1 2 3 4 5 instances. That means 5 by 14. So ultimately this info become I 9,5, which is this, and after solving this log 2 value, if you see, you will see it is coming 0.940. Okay, this is the overall information, overall entropy. Okay, now we will be finding entropy for individual attribute. Let's first find the entropy of attribute age. So attribute age, what is the entropy? Attribute age entropy is what is the formula? Let us go to the formula again. Attribute A, this is the formula. Okay, so formula says that after using A to split D into V partition, so dj by D info dj. Let's see, dj by D info dj. So dj by D, so dj by D info dj. Okay, okay, so yeah, so here dj by D info dj. So what is happening here? 5 by 14. 5 by 14 for here 5 by 14 age, right? Age okay, age attribute, if you see, sorry, age attribute, if you see this one, 5 by 14. So I'm sorry, 5 by 14 means 1 2 3 4 5 youths are there. So now we are looking at this age attributes categorically. So how many youths are there? 1 2 3, 4, 5. Okay, okay, fine. 5 youths are there. So here I think 5 by 14 youths, 5 by 14, and then I2, 3. Out of this 5, means age less than 30 has 5 out of 14 example, with 2 yes and 3 no's. Yeah, so here here we have 2 yes and 3 no's. So 5 by 14 is for youth students, youth, and youth. 5 instances. Out of those 5 instances, 1, 2 no's, and 1, 2, and then 3 yes. Okay, 2 no's and 3 yes. So that's why it is written 2, 3. Okay, 2, 3 for the youth. So we are going to calculate the information age now. So 2, 3. This is done. Next will be for middle-aged. So middle-aged example, how many? 1, 2, 3, 4. So 4 examples, 4 instances. Out of that 4, so first 4 instances are there. That's why 4 by 14. 14 is the total number of instances. So 4 is the middle age. 4 is the middle age. 14 total. 5 is the youth. 14 total. And then I 4, 0. That means out of this middle age, 1 yes, and then 2 yes, and then 3 and 4. All are yes only. There is no no. That's why it is yes for it is coming 4, and this is 0. No no's are there. Similarly for senior, we have how many? Yes, we have how many senior? First of all, 1, 2, 3, 4. 4 seniors. Out of that, 1, 2, 1 no. Okay, 1 no, 2 no's. 2 no's, 2 these things are there. I think 3 yes, 2 no's are there. So total 5 seniors are there. Out of that, 3 3 yes and 2 no's are there. I suppose so. So calculating this information age, it will come 0.694, this value. Okay. Now what you have to do, students, as I said, we have to calculate the gain here. Okay, this is the gain. This is the gain you have to calculate. So which is nothing but the total information minus the information gain for the attribute A. Okay, so that's what you are doing here. So here information gain is age is nothing but info D minus info age D. So info D has come how much? 0.940. That means this is 0.940, this one, and info age has come 0.694. So if you subtract, it will be 0.246. This is 0.246. So similarly, information gain also you have to calculate for income, because income is the next attribute. Also you have to calculate for student. Also you have to calculate for credit rating. You don't have to calculate for binary bias computer, because this is the target attribute. So this is the target attribute. Okay, target attribute, right? So all information gain you have calculated, and out of those information gain, we have seen that maximum information gain is nothing but the first attribute, age. So this attribute is having maximum information. Let me rub it. One second, hold on. It is all okay. So age attribute, it should be our target attribute. Okay, whatever happens, split and all, you have to do age with age. Other attributes are not having that much information gain. If you see, this is 0.246. This is income, it is 0.029, and student, it is 0.141, and credit rating, it is 0.048. So you'll be calculating obviously with the same method, and you'll get that. Okay, so this is the case. That's why we have taken. Similarly, we can compute gain for income and all, because age has highest information gain among the attributes. It is selected as splitting attribute. So that's why which attribute should be splitted further, where should you go? You cannot go randomly. So initially, if you see the tree, here is the tree. So age is actually has been splitted. Why they haven't splitted income or student or credit rating or bias computer? Oh, sorry, bias computer won't come. Credit rating. These all 3 attributes has been ignored. Only age has been splitted further. So whenever instance comes, which direction it should go? It should pick age, because age is having the maximum information gain. So once it is done, then we can have this. So because age has the highest information gain among the attributes, it is selected as a splitting attribute. Note n is labeled with age, and branches are grown for each of the attribute value. The tuple are then partitioned accordingly as shown in figure 8.5. Notice that the tuple falling into the partition for age equal to middle age all belong to the same class, but because they all belong to the class yes, a leaf should be therefore be created at the end of this branch and labeled as yes. The final decision to return by the algorithm was shown earlier in figure 8.2. Okay, so this is the final result. So this is the final result they have shown even. This is the final result. This is the final result. Okay, this is the final result they have shown. So age is an attribute that we should look at. Okay, now here so you see youth, middle age. So what they are doing, so with the youth they have with the youth all the values has been segregated from the table. Okay, with middle age also all the values has been taken out. So separate three tables have been made out, from which separate three table has been made out from this. So youth, with youth, with youth, with youth, everything has been taken out. Yes, no, everything has been taken out. New table has been formulated. This is the new table. Okay, this is the new table. With middle age, new table. With seniority, new table. Okay, so the final decision tree is written by this 8.2 only. The attribute age has the highest information gain and therefore becomes a splitting attribute at the root node of the decision tree. Branches are grown from each outcome of age. Tuples are shown partition accordingly. Okay, this is the case. Now, but how we can compute the information gain of an attribute that is continuous valued, unlike in the example. We have all categorical value. If you see the data, this is next thing I'm telling you. So this is the attribute. This is categorical data. See, this is categorical. What it says, if it is not category, this is also category and this is also categorical data. All data are categorical data. What it says that if instead of categorical data, if we have continuous data of an attribute which is continuous valued, unlike example. The example it is not there. Let us say if it is a continuous value means what? Here let's say this one. Let's say this youth is some values, let's say 30 or something, 0.30, the contain values. Instead of categorical data, we have the values. So in that case, the situation will be little bit different. Suppose instead that we have an attribute A that is continuous value rather than discrete value. Okay, for example, suppose instead of discretized version of age of the example, we have the raw value for this attribute. For such scenario, we must determine the best split point for A, where the split point is threshold on A. We first sort the value of increasing order. Typically, the midpoint between each pair of adjacent values is considered as possible split point. Therefore, given V value of A, then V minus 1 possible split are evaluated. For example, the midpoint between the values AI and AI plus 1 of A is AI plus 1 divided by 2. If the value of A is sorted in advance, then determine the best split for A requires only one pass to the values. For example, for each possible split point A, we evaluate info AD, where number of partition is 2, that is V equal to 2 in equation 8.2. Okay, so equation 8.2. Okay, this is there. Okay, so okay, so we will be having split and we will be just arrange them in sorting or sorted order, increasing order. Okay, the information gain measure bias toward test with many points, and then there is a participation of the gain ratio also. Okay, in case of the information gain measure is biased toward test with many outcome, that is, it prefers to select attributes having large number of values. For example, consider an attribute that acts on unique identifiers such as product ID. A split on product ID would result in large number of partitions, each one containing just one tuple. Because each partition is pure, the information required to classify data set D on this partition would be info product ID D, which is 0. Therefore, the information gained by partitioning on these attributes is maximal. Clearly, the such partitioning is useless for classification. Anyway, these are next level things they're telling, but info and then gain ratio A is gain ratio A by split info A. So this is just the attribute with the maximum gain ratio is selected as the splitting attribute. So now the discussion is about splitting attribute, how to choose, and if it is not categorical data, if it is continuous data. So but anyway, up to this much, I hope you